So this one says the term with the y5 in 5 minus 2y to the 8 is. So the only thing I don't know here is k. We agree? I know x, I know y, I know n. If they give me a binomial, I know x, I know y, I know n instantly. So let's figure out what those are. So this is my x. My y is negative 2y, because remember I have to have a plus sign between. And my n is 8. My k, I don't know, but I can figure it out quite quickly. So what can I do? What do you do if you don't know something? Fill in everything you do know into the formula and hope to God that there's somewhere in there that God can help you and bless you with possibly the knowledge of what k would be. Because the only thing we're missing here is k, and they gave us some extra information, so that's probably going to help us get it, right? The extra information they gave us was y5 is the term they want. It has to contain a y to 5. So let's fill in everything we know and leave the k's as blanks because we don't know what they are. So we're going to have 8c. I'm going to fill in a box instead of a blank. Got to fill something in there. And then we're going to have 5 to the 8 minus box. Negative 2y to the box. And for every one of those black boxes, it's the same number. So if I figure out what it is for one of them, I'm done. I can just fill it in, I'm good. We agree? This one says the term with y to the 5. Does it say the term, what term contains y to the 5? If it says what's the term number, then you would tell me term 6 or term 5 or term 4. Yep. But does this one ask you for what term? Like what term number, sorry? No, it asks you for what the term is. So you actually have to solve it out and give me what the heck the term is. Like negative 40x was for our quiz. Okay? So I need it to contain y to the 5. This is actually really easy. Only because both of these don't contain a y. This is the only one that contains a y. We agree? So what does that box need to be in order for it to contain a y to the 5? A 5. And then if this box is a 5, what's this box? A 5. And then what's this box? A 5. And now I have it. Solve it out just like I did before. Because once you fill in one box, they're all just k. You just fill them in, right? What's 8c5? 56. And then this is going to be 8 minus 5, which is 3. 5 cubed is 125. And then we have negative 2 to the 5. Remember, if you just go negative 2 to the 5 in your calculator, or sorry, if it was a 4 and even. If you went negative 2 to the 4 in your calculator, it would tell you it's negative 16. Remember, you have to put the negatives in brackets if you're going to raise into an exponent in your calculator. But you also need to just use genuine math knowledge. Negative 2 to the 5 is negative 2 times negative 2 times negative 2 times negative 2 times negative 2, right? Which is a negative times a negative times a negative times a negative times a negative. If you have 5 negatives, your answer is going to be negative. So if you have an even number of negatives, when they multiply together, they're going to make a positive number. But if you have an odd number of negatives and you multiply them together, it's going to give you an odd number. Okay? We can't just rely on our calculators to know that if I raise it to an odd exponent, it stays negative, but if I raise it to an even exponent, it goes positive. You should just know that by now if you're in pre-calculus and intending on taking calculus in university. So negative 2 to the 5 is negative y to the 5. Multiply my coefficients. 56 times 125 times negative 32 is negative a large number. Anyone get it? What'd you get? Now the answer to this question back here actually was negative 40, not x. This one way back here, because I actually asked you for the coefficient. The coefficient is the number in front of the term. So the coefficient would be negative 40. So this answer is done here. What would the coefficient of the term with y to the 5 be? Negative 224,000. So if they ask you for the coefficient, which sometimes they do, they literally just want the number in front. Why do you think they would possibly ask for just the coefficient? Because numeric response. If it's a numeric response box, you can't fit a variable into a numeric response box. So that's the way to do it. Can you put a negative into a numeric response? No. So do you just ignore the negative and still write the number then? No, you're wrong. Go back, try again. Like the only way that that would work is if they said the answer to this is A, and they want the absolute value of A. That's the only way. If they ask you for the answer to the coefficient is in the value A, determine the absolute value of A, that's them telling you, hey, your answer is negative. I'm going to turn it to a positive so I can fill it into the numeric response box. They don't often do that, though. They'll work the question so that it ends up being a positive number rather than just forcing it to turn into a positive. All right? Okay, constant term. What's the constant term? Anyone know the definition of a constant term? Think about constant term in the word constant. Constant would mean stay the same, correct? So if you have, yeah. Sorry? Nope. If I gave you a polynomial like x squared plus 3x plus 7, the x squared plus 3x plus 7 has variables in it, right? So if I give you the number 2 with a 3x squared plus 2x plus 7, with a 3x squared change? Yeah, I'd fill a 2 in. It would change that, right? So say I had 3x squared plus 2x plus 7, and f of x equaled that. So we kind of start at grade 10. I could fill in any value for x. Would it change this number and this number? Yeah, if I filled a 1 in, this would be a 3 and a 2. If I filled a 2 in, this would be a 12 and an 8, right? Those all change, correct? Which is the only one of those terms that remains constant no matter what variable, what number I put in for the variable. 7. It remains constant because it doesn't have a what? It doesn't have a variable. So I don't ever plug anything into it to multiply it by something, correct? So it remains constant no matter what I fill in for x. We agree? So the constant is the term without a variable. That's all it is. Make sense? It's one that doesn't change. Okay. They want the constant term. I know x, I know y, I know n. I have no clue what k is. But can I still fill in stuff and put boxes in and hope that I can figure out possibly which one would get rid of all the variables? Yes. This is one of the harder ones. So I'm going to go plus and minus. So this is my x, this is my y, this is my n. So I'm going to get 15c box. 2x to the 15 minus box. Negative 1 over x squared to the box. So I told you before when we had an x to the 4 over x to the 3, it's just a side note. These canceled, but I was still left with an x on the top. We agree? If I had had x cubed over x to the 4, these would cancel and I'd be left with 1 over x. We agree? So ultimately, I'm trying to get rid of all the x's because I want a term without a variable in it. We agree? So I need the x's in the denominator to actually be equal to the exact same amount of x's in the numerator so they cancel off. We agree? So right now, this one is an x to the 1 currently. Yeah? And this one is an x to the 2 currently. If I actually canceled them at this very point, I'd still have an x in the denominator, wouldn't I? Which would not be a constant term. We agree? So I need to figure out what I can fill into these two red boxes. Same number, though, it has to be, right? That when I bring it in, I end up having the same numbers. Same x to the whatevers. Okay? So I know that this number here, right here, is going to have to be smaller essentially than this one. We agree? Than this combined 15 minus box. This is going to have to be smaller than this one. Because when I raise this one to a number, it's going to grow twice as fast than this one. This one's x squared originally, and this one's an x. So you could just guess and check, technically. So let's try 0. You could work your way through. So I put a 0 here. Don't do this. And I put a 0 here. This would be x to the 15, and this would be x to the nut that's gone. Would that work? Did they cancel? Are they the same? No. So let's try a 1. This would be x to the 2, because 2 times 1 is 2. And this would be x to the 14. Do they cancel? No. Let's try a 2. This would be x to the 4, and this would be x to the 13. Did they cancel? No. Let's do a 3. This would be x to the 6. This would be x to the 12. Did they cancel? Let's try a 4. This would be x to the 8. This would be x to the 11. Are they canceling? Nope. What about a 5? X to the 10, x to the, oh, be still my heart, we found it. Okay, so we're going to fill a 5 in to every red box. What I would not suggest you do is go like 0, 7, 3, 4, 5, 8, like randomly guess numbers. It will take you way longer. You could perchance guess the right one, or you could be like guessing around. It's just better to systematically check them, then you'll get to it eventually. You might notice, hey, 1 is really far away, so maybe I'll try 3, then 4, then 5, and skip over 2. Sure. So 15C5 is what? Now, this is 15 minus 5, which is 10. So I have to remember to go 2 to the 10, though, right? We can't forget that. What's 2 to the 10? A really large number. How much? X to the 10? 1, 0, 2, 4. Oh, I really switched those. And then this one, I have to do the negative 5 again. So I'm going to get negative 1 to the 5 is negative 1 over x to the 10. We agree? And this is good. You're good if these go away. You're wrong. Go back, try again if you thought you actually were right, and they don't cancel. And then we just multiply those numbers. So it's going to be negative 3003 times 1024. It doesn't have a variable. Something must be wrong. Oh, wait, that's what you were trying to figure out, the term without a variable. So it shouldn't have one. It's a good thing. That's what you were trying to get. Now, guys, if I asked what term number this was, what if I said which term contains the constant term? It would be term 6 because k equals 5. The little red box is 5. It goes one more. Okay. This is the last one I want to go over. I'll go over number 7 first. Actually, number 6, because 6 doesn't give you the term. Okay. This one's just different. So these ones really aren't substantially different than yesterday. You just had to figure out k, right? This one's totally different because they give you the actual answer and you're missing a piece of the binomial. Okay? So in this case, one term in the expansion of x plus a to the 10 is this. They give you the actual answer. Until now, we've just found the answers, right? We've always plugged into the formula, got the answer. We agree? Every single time? Either gave us the term and we found the answer, or we defined k and we found the answer. But ultimately, in the end, we always just found the answer. Yes? Here, they're giving us the answer. So let's fill in what we do know. We know that this is x, this is y, This is n. This is answer. Right? So let's fill in what we do know. We know we have 10c box, x to the 10 minus box, a to the box. What's the difference now? Equals answer. They gave us the answer this time, right? That's the only difference. Equals 3, 2, 8, 1, 2, 5, 0, x to the 4. 3,281,250 x to the 4. Our answer leads us into something here. Try and help me out. I need to figure out what the heck those boxes need to be. Any way of helping me here? Yeah. Yes, we need to find something that makes x to the power 4 because our answer is x to the power 4, right? So what's it going to be? 6, because 10 minus 6 is 4. Okay, now we actually have to solve for a in the end here. So we'll see. What's 10c6? We're just going to go like this. I don't really care about that. What's 10c6? 210? X to the 4, a to the 6 equals that. What's great is I can actually divide an x to the 4 off both sides because both sides have it. Divide x to the 4. It goes away. And I need it to go away because the only variable I can have is a because I'm solving for it. If I have two variables, you can't solve for it, right? It's just like having two unknowns in chemistry or physics. You can't solve unless you only have one unknown. So we have 210 A6 equals 3,281,250. Divide by 210. And we get a to the 6 equals what? $15,625. Now, you could take the 6th root of it, or there's another thing I could do. If I raise this, it's 6 over 1. If I raise it to the exponent 1 over 6, which you're going to need to do when you get to exponentials, so that's what I'm teaching you to now. What's 6 over 6? 1. So this would become 1, wouldn't it? So if I raise this to the 1/6, I have to raise this to the 1/6. And a equals something. Is it 5? You could also try and just like guess and check till you get it as well. And then the rest of this, is it not that?